I'm staying here because Elegoo sent me their new Centauri Carbon and dared me to make something cool. 500 hours later, I have a little tiny PC, a little itty bitty custom keyboard, a itsy beansy custom mouse, and a special secret which we'll show at the end. Just one more thing. So here it is, Retrotosh, a 3D printed tribute to the Macintosh Classic or Macintosh 128K. And this project was inspired by my dad. He's the reason that I'm into computers today. My earliest and best memories are of me sitting on his lap while he would program little sounds and noises to make me laugh on our Macintosh 128K. He would make lots of software for me and my siblings throughout the years that taught us to read very early, to play music, to learn history, and to love technology. Now, we've owned tons of Mac over the years, but the 128K is the one that means the most to me. So instead of just replicating it, I want to reimagine it. A modern, 3D printable version as a tribute to my dad. I saw a cool 3D printed ITX case on Etsy, purchased it, message from the designer, Andy, and it said something like, "Hey man, you only make something if it's the highest possible quality or you don't do it at all. Respect." Alright, so this project would have been really easy just to model over the weekend and throw some parts in, but no, I want it to be refined. I want it to be replicatable. I want it to be perfect, as Andy had accused me of doing. I want to live up to that expectation. So I went all in. No ugly supports, no post-processing, just pure design straight off the printer. For 2 months straight, my printers were running non-stop. The Elegoo Centauri Carbon was the workhorse for this project, and of course I made sure that all the final prints were on it. I'll do a full review, but later, when I do a huge comparison of all of my 3D printers. Here's the short version though. The good. It's a Bamboo X1C clone. Christine from Elegoo even told me to compare the two. First layer aside, and despite the fact that it prints sometimes faster than the X1C, the quality is outstanding. Number two, it actually works. It's fast, reliable, and no major failures yet. Number three, it's quiet. Take a listen. This is actually why I like this printer so much. My printer's on the opposite side of my bed, so I want them quiet, and I think it's because of the cast aluminum base. Number four, setup is stupid easy for stupid people like me. It took 15 minutes versus Bamboo's 2-hour tape unwrapping marathon. Okay, the bad, no 2-port on the bottom of the runout sensor. This is dumb considering that it's advertised for carbon-infused filaments, which need to be dry. Number two, the build quality. And I'm just talking about aesthetics here, it's just okay. It's not as polished as Bamboo's beautiful printers. And finally, the nozzle changes are not a nightmare, but one step down from that. They're not easily accessible, and the short, tiny wires in the back make it very difficult and very frustrating. But overall, an absolute game changer at this price. We liked it so much, we actually spent our own money purchasing a second one. Now for the design process, and after a few days, I thought it was 90% done because it was going very well. But that was past naive me. Current me knows that the last 10% takes 90% of the time. And here's some of the stuff that was frustrating or went wrong. First out was the slide-out SSD bracket. Not specifically this, but because of how it was modeled, everything is on a slant or an angle. It's a very organic shape. There was a lot of adjusting that needed to be made to fix all the kinds of errors that occurred because of this in the case. Power supply fitment. Well, I forgot to model the screws on the bottom of the motherboard, and that meant I had to redo most of the design. Very rookie mistake. Print banding issues was a huge problem that needed to be solved, and that went hand in hand with prototyping. Your geometry will affect the model print quality, so I had to go back and make tweaks to avoid artifacts. Finally, the handle design. I spent 16 hours overthinking it, when all I really need to do was just glue it to the top. You know, sometimes the simplest solution is the best. The hardware of this build is based on the ASRock STX motherboard because it's small, powerful, and has a great DIY community. It has 2 M.2 ports and micro SATA ports for storage. Kari actually sent me one preloaded with a CPU, RAM, and an SSD, which I really appreciate because this project already got to be way too expensive, so thanks Akari. The computer is cooled by a Thermalright AXP90 X36 edition with a custom air shroud that can pull air from the back of the case and push it down off to the sides. Of course, the power supply would overheat, and I was kind of concerned about the SSD too, so at the bottom there is a knock to a 60mm fan, which blows air directly on the SSD and moves through the power supply out the side vents. There is lead wires soldered from the back of the DC jack. You can watch this video to see how it's done. That allows everything to be internal. I don't have to run an external power brick. It's super neat and clean this way. Bezel, okay, this is definitely the hardest part for multiple reasons. One, I wanted the screen to fit perfectly with no pixels blocked off or a ring of black pixels around the edges, which meant spending a lot of time with a pair of calipers and making the proper adjustments and coming up with the proper way of attaching and clipping the screen into the monitor. I'm happy to say it's all press fit in, you don't need to use screws, and you can remove it easily if you need to. Another big problem was lining up the front I/O on the motherboard. This seems like it'd be very simple to do, but this is real life after all, and lining everything up and having the bezel stay on and be perfectly crisply united with those front ports took a lot of tweaking. One thing that I'm not super duper happy with is that you do need to hold the front bezel on when you're plugging things into the back. There's a couple solutions for this, but they all have trade-offs, so I'm going to live with it for right now since it seems to be a very simple thing to do. Okay, this project is not just about the computer itself, but also the accessories. My eyes kind of glazed over when trying to learn about custom keyboards, so I recruited my friend and Discord therapist, Alvin, to help sort me out. He turned me on to the Vortex Macintosh replica keyboard, which has Gateron G Pro retro white switches. Whatever that means. Look, if it's too late for me to learn how to play Magic, then it's definitely too late for me to learn all the key terminology. I was in love with this keyboard for many reasons, but it was just too big. It dwarfed the whole project. I need something tinier. So I went to my custom keyboard friend on Discord, Key.
I had to grab a 30% keyboard kit like this one, but I ran into a snag, couldn't find out what made this board upset. Now I had a backup plan, and that was to use a different keyboard PCB. This one is a 35% hot swap called the QAZ, and as you can see here, I already assembled the board with switches and blank keycap, which matches the Apple aesthetic. So this keyboard did not ship with a firmware or key map, so I had to make both of those myself. Once I got that dialed in, I was able to go on valve.rock, which is a free tool that lets you edit the layout of any QMK or Vial compatible PCB. So this keyboard is obviously not done because it needs a case and a cable, but I am sending this off to Josh so he can put the finishing touches on it.
Man, I had no idea how much work it was going to be plotting out multiple layers for a 40% keyboard and doing the layout for the keys, so I'm definitely glad I got Key's help. Thanks, buddy. The base design for the keyboard actually went really smoothly. I used BBs to weight it down, and then I also used a stainless steel plate, which further increased the density. And now it's a solid, very premium feel. One of the challenges was printing the tall, skinny cover, making sure that was band-free. The solution was to use the Z-axis with my tuned filament and then slow the print down as it got taller, but not too much. But the result, definitely worth it. When I was working on all this, I asked NFC Gabriel to help get me started on the mouse, and he did an amazing job. Now the cool thing is that we decided to use the bamboo mouse kit, so if you like pain and suffering, you're in luck. You can replicate it. The biggest challenge was the laser lens placement, which was truly a nightmare. A fraction of a millimeter off doesn't work. Also, now that I think about it, the battery was also a problem. It was so big and our mouse was so small that really didn't fit, and Gabriel had to work some big magic to get it to stick in there. And Also a problem were these switches. Those switches took endless tuning. Endless. Gabriel and I could pave our driveways with the leftovers. Like the Retrotrash shell and keyboard, there was a lot of prototyping to get the final product looking like a consumer product, but it was definitely worth it, so I'm glad that we stuck it through and tried all the different orientations that we did. The functionality, however, is garbage. The button angle is all wrong, and this was my fault because I only gave Gabriel a top-down picture to reference, and turns out that the original mouse, is wedge-shaped, not brick-shaped. I might have actually ended up designing a worse mouse than Apple. Maybe they'll hire me for the Magic Mouse 2.0. I actually started to put windows on this thing. I know, it's not a Macintosh, okay? Hello. But then I realized, why? This would be perfect to put Cinnamon Mint on, so I did that. And it was super duper easy. Even gaming was great with Steam Proton. Really awesome that the Steam Deck has made that so simple. It was perfect, and it definitely made switching to Linux much less scary, and I'm going to do it professionally much sooner now. The project was looking really good, but it still was missing something. The Macintosh startup sound. I bought a tiny Adafruit audio board, a mini amp, and a tiny speaker. Now, this should have all been very simple. It was not. It worked perfectly when powering from an actual USB connector, but when I wired it directly to a 5-volt source, everything appeared to work, but there was no audio. So I had a janky hack solution for that. Perfect. So now when I press the power button, it loops endlessly. Clearly I have no idea what I'm doing. But I've come this far trying to impress Andy with my over-engineered solutions, so I ain't giving up. How about this? Dual power switches that trigger both the PC and the soundboard. I need a power switch anyway. Now what to do with all the prototypes? So many failed prints. So much guilt. So I turned one into a lamp. This is the perfect way to use up all those extra prints that didn't make the cut for the computer. For the screen, I use PETG. The tray is made out of PLA CF because it's super stiff, but also heat resistant for this, 1-watt light bulb. The back plate clamps the power cord down, and it has this cute little Mac OS 8 face on it. I know it's not very accurate, but hey, it was my favorite OS as a kid. The startup sound also isn't accurate, but again, that's my favorite startup sound, so I'm gonna roll with it. Now it's time to give this to my dad, and if you want to print your own nightlight, you can find the files on MakerWorld. If for some reason you want to make the full PC, those files are on my Patreon as a special thanks to my patrons. More special thanks, Christine from Elegoo. I hope that you like the project I made with the Elegoo Centauri Carbon. Of course, thank you to Alvin, Key, Gabriel, and Ikari. Without you guys giving your very best, this project would not have happened. I just didn't have the bandwidth, and you guys really stepped up and knocked it out of the park. And of course, thank you to my patrons on Patreon for funding this insanity. And most of all, thank you, Dad. I'm so grateful to God for blessing me with you as my father. All right, everybody, we made it. Nothing came through the glass. Storm is still going pretty strong, but I'll see you guys next time. Peace. I have my headset on, the microphone in front of me, and I apologize for that. It's because the wind noise, as you probably can hear, is crazy right now, so I have to just get the mic as close as possible.